Fantastic.
All right.
David, thank you so much. Thank you all for being here today. It's a real pleasure to be with you and present this exciting technology. My name is Chris Lannon, and I lead a group at Carleton that does research contracts as well as technology transfer. And we'll be pretending I'm an expert in this exciting area as our faculty member is conflicted with a lecture this afternoon. So I'm sure it's no secret to anybody on this call, I'm not going to the next slide, that the wireless communications market is growing exponentially. And depending on what point in time you want to pick, we're certainly seeing double-digit growth for the last almost 2 decades in this sector. And the major factors driving this wireless connectivity market's growth are an increased demand for wireless sensor networks and the development of a smart infrastructure, significant increase in internet penetration rate, and a growth in the adoption of the Internet of Things, as well as increasing trends like work from home, virtual learning, and this type of session that we're on today. However, this growth certainly doesn't come without any challenges. We're presently at a point where we're starting to see demand for bandwidth outstripping supply, certainly as we increase our rollout of 5G, and certainly with the implementation at some point in the future of 6G, this phenomenon will certainly not change. Secondly, wireless operators are aggressively looking to reduce costs. Just on Friday, I was sitting down with North American lead for a multinational operator, and he says their clients, all they want to talk about is how do I reduce power costs? We're now at the point where an industry that was historically led by capital expenditures is now laser focused on OpEx. So what do we need to do to increase these power costs as the demand for bandwidth is increasing? Lastly, most users aren't consistent to use the quality of service that is allocated to them. And what I mean by that is the bandwidth that is allocated to them. I'll give you an example. If my 17-year-old and I are in the same room on our devices using the same service provider, we don't necessarily need the same quality of service allocated to both our devices. I'm an old man, she's 17, her eyes and ears work fundamentally better than mine. She should be allocated a higher quality of service than I am, because providing it to me, quite frankly, is a waste. And so if we can optimize this quality of service, we're going to increase the efficiency and the efficacy of these wireless networks. We're going to get better at using the resource allocation. And ultimately, we may even be able to optimize personal level satisfaction. So if you are a student of wireless network optimization methods, you might be familiar with this Open Systems Interconnection model, or OSI model. Historically speaking, we focused on optimizing networks at the bottom part of this table here, really trying to look at what's the physical structure so that we can allocate as much bandwidth as possible. The technology that we've discovered at Carleton actually flips this on its head and focuses at the end user as a way to provide practical optimization for users that are using this. For instance, let me give you another example. Let's say there's an event that happens at Queen's Park, and that requires emergency services to intervene. Obviously, you've got a big demand for resources from emergency services. You've got a big demand from people who are at Queen's Park, who are probably trying to communicate. And then you've got the rest of the city that are around them, possibly unaware. Wouldn't it be amazing to be able to geofence Queen's Park and allocate resources proportionally based on what is known about the possible reality going on the ground? And so what our personalized network technology does is it uses a novel zone of tolerance model to quantify user satisfaction, and then a framework to, in an unobtrusive manner, capture that feedback and feed it back to the network in real time, okay? By using machine learning and predictive analytics, we're able to provide that feedback to the network operator, and then that operator can make real-time allocations of that bandwidth providing a bandwidth higher to the users that truly need it and decreasing it for users that don't actually need it. We think that this technology is the first key step towards true system optimization of a wireless network, and it provides for most efficient resource usage with greater user satisfaction. We have patent pending technology in North America as well as Europe. And we're currently looking for a partner who can help us with validating this technology using real cellular data. We've not yet been able to get onto an operator's network due to data privacy. Next, we need some assistance in determining the best path for commercialization of this technology. We've got a number of use cases underway right now and see pros and cons for both public as well as private networks. I think we're looking for an entrepreneur with some experience in this space who might be able to guide us, perhaps under multiple directions at the same time, and as well as support the IP protection as we further develop this interesting family of patents. The research team is led by incredibly well-known Professor Halim Yanakamiroglu from our Department of Systems and Computing Engineering. He's got a long history of contributions to the wireless networks, was heavily involved in drafting the 5G standards, and is currently doing the same thing for 6G wireless networks. And Teresa White from my team is leading the commercialization the commercialization activities. So I'll stop there in the interest of time. Happy to take any questions you might have.